Okay, dear students, it is the last class where I finished chilled water piping in general. This is chilled water piping. Now, in the next class, this class I'll be going on with condenser water piping. So I am rubbing this chilled water piping diagram. There is similarity between condenser water piping and chilled water piping diagram to some extent. So that's I have put this drawing intentionally for you, so you can see this and you can correlate to this. Now I am rubbing it and put the relevant portions here that you will see. This I am putting condenser water diagram. For your relevance, you have to see this condenser water diagram. How I am converting the chilled water diagram into condenser water diagram. So there's many things of the same diagram you can repeat. To make it easier, I have done it. I have rubbed it, the chilled water part of that, now putting condenser water part of that in that diagram. Now you can see this is condenser water system in total. Now, what is condenser water system? What is chilled water system? So that you are not confused, I am going to tell about the vapor compression system, how it works. You can see in the vapor compression system, there is the evaporator, there is condenser, in between there is expansion valve, and there is the compressor. This compressor indicated by C. You know, in the evaporator, the refrigerant comes, gets evaporated. When it gets evaporated, it sucks heat from outside. As it sucks heat from outside, the outside environment gets cooled. That's what is happening in a refrigerator. I told you earlier, but I am repeating it so that you understand again. In the evaporator, as the refrigerant comes, refrigerant gets converted into vapor. When it gets converted into vapor, it sucks the latent heat from outside, and outside temperature drops. Then this hot refrigerant, which is in the vapor phase, comes to compressor. In the compressor, it is compressed from this state to this state. The pressure increases. Then it comes to condenser. In the condenser, it is cooled. After cooling, the liquid part of that comes to expansion valve. And from the expansion valve, it expands and comes to refrigerator, evaporator again. This is how the whole circuit works in a vapor compression system. Taking that into consideration, remember, this whole structure is defined as chiller or chilling machine. That is CH1 or CH2, chilling machine. That means in chilling machine there is an evaporator and there is a condenser. You're getting it, huh? I'm trying to make you understand what is difference between condenser water system and chilled water system. You already read chilled water system in my last class. Now you are coming to condenser water system in this class. In the condenser water system, there is a condenser and there is an evaporator. Evaporator was chilled water system. When we pass water through the evaporator, it is a chilled water system. What happens? In evaporator, the refrigerant sucks heat from water, water gets cooled. And the cold water is circulated through the whole system. In case of condenser, the water gets heated up, taking heat from the condenser. What is happening? This refrigerant which comes in the evaporator, then goes to compressor, the temperature increases, it comes to condenser, it rejects heat to the condenser. So it rejects heat to the water. So in case of chiller, the water gets cooled. In case of condenser, the water gets heated. Because we are cooling the refrigerant of the condenser with the help of water from outside. Now that hot water is to be cooled again. Because we have to supply cold water to the condenser to cool it. Better example of that you can see in your house in air conditioning machine, that is AC. You have put the window AC or split AC. You go to the outside unit, outside of the window AC or split AC, you will see hot air is coming out. Why hot air? Hot air because the refrigerant, this is the condenser, the outside part is condenser. In case of split, the outside unit is condenser. In case of window, the back side is condenser. So what happens? The refrigerant comes to the condenser, the air passes through that, picks up heat, gets heated, and condenser refrigerant gets cooled. So when you stand behind the condenser, you get the blow of hot air. Now in case of these, the same thing, water is passing through the, instead of air, we are passing water through the condenser. So when we pass water through the condenser, what happens? The water picks heat from the condenser and condenser refrigerant gets cooled. So that hot water from the condenser is to be cooled somewhere. Again, to recirculate it, see, we cannot continue to supply cold water to that because that much water is not available, number one. Number two, that is very costly affair. So we have to recool the condenser water which has become heated and again resupply to condenser. To do that, we are using cooling towers. Now cooling towers you must have seen. You must have seen cooling towers. Cooling towers you have seen in case of many buildings, big buildings, you go where air conditioning is done, you will see a outside structure, outside. Generally it remains in the ground or in the terrace. So sometimes you find in the ground a outside structure is there through which water is continuously falling. Like streams of water is flowing. You will get a huge sound of water thud. That water is coming out. That is cooling tower. That cooling tower is being used in this case. Cooling tower, in the cooling tower, the hot water is passed and then cooled, and then cold water is passed to the chilling machine condenser. So in chilling machine, there are two lines. One is condenser water line, one is chilled water line. Now we are reading the condenser water line. The last class we read the chilled water line. In chilled water line, we chill the water. The chilled water is passed through the HUs and FCUs, and then we bring back the hot water. In case of condenser, we bring back the hot water, we bring back the cold water from the system, pass through the chiller. Cold water will pass through the chiller, and the water gets heated. That hot water is passed through the cooling tower. Cooling tower cools it, and cold water is again recirculated. The cycle continues. This is how a condenser water system works. This is how a condenser system works in general. So, in case of this chilled water and condenser water system, you have to understand what is the philosophy of cooling tower. What is done in a cooling tower? There is a blower at the top. There is a blower at the top. The blower draws or sucks air from outside. As the air flows from outside, then I drop water in small triplets. There is a very, very small sprinkled water is passed through these sizes. Here is a pipe through it water is coming, which is hot water. This hot water is passed through these spray nozzles. Sometimes the spray nozzles rotate with a motor. So rotate gives a circulation of the spray. The more the circulation, more is the opening of the surface area to the air. And then why we sprinkle water into small droplets? Just to increase the surface area. Why the increase in surface area? Because you know Q is equal to UA delta T. If I increase area A, the heat transfer Q increases. Because Q is directly proportional to A. Taking that into consideration, we are dropping the water into small sprinkles. There are nozzles here. These nozzles divide into small sprinkles. You remember IC engine. In case of IC engine, in case of compression ignition engine, what happens? The fuel is passed into small droplets so that it gets well meshed up with the air and the combustion takes place. Why well meshed up? Because the surface area increases, the heat transfer increases, and combustion happens easily. Taking the same phenomenon to somewhat in this extent, here we are passing the water into small droplets, increasing the surface area and transferring and making the more heat to transfer. So what happens? This air, this cold air which is coming inside, picks up heat from water, itself gets heated and passes through the blower to outside. This is the cooling tower structure. In the cooling tower structure, these are outside fields in which there are small apertures. Apertures means holes. This blower is sucking air, it's moving, it's sucking air from here. This air is going from this part, and passing through this sprinkled water. So, small atomic sized particles of water gets exposed to cold air. There is meshing up, there is mixing, and as a result, there is cooling. So, water gets cooled here, the cold water gets, here is the cold water. Cold water. Here is the cold water. Here hot water was coming, it becomes cold and comes here. Now, this air picks up heat and goes outside, and water gets cooled. This cold water comes here. The same principle applies in case of the cooler you use in your house. What happens in the cooler? You do the same thing. Water you sprinkle, through the water the air passes. In this case, the air gets cooled. But air also picks up heat and you get cold water at the bottom of the cooler. To some extent, it works like that. The cold water, it gets collected here. Then, this water is passed through the condenser again and cooled down. The cycle gets completed again and again like that. Here is a pot strainer. We are putting a pot strainer here to filter the water. Water is getting filtered through the pot strainer and coming to the system. Now you can see the cooling is happening. It's a cooling tower here, but there are places like Gulf countries where you cannot use cooling tower because first of all the water is not abundant. What water is abundant is marine water. Marine water means sea water. Sea water is generally saltish, and in a cooling tower it will finish the cooling tower material totally because of the salty character. You have seen in the cooler in the house, where in Delhi many places salty water is used, the cooler ka 12 baj jata hai. It becomes very spoiled cooler as a result of salty water. In this case also, the salty water spoils the whole cooling tower in Gulf countries. So what happens in Gulf? They are not using the water cooled system. This is called water cooled system because you are cooling water through cooling tower. Water means condenser water. In case of Gulf countries, instead of water system, they are generally using air cooling in chilling machine. That means in condenser is cooled with the help of air, as it is done in case of your house air conditioners. घर में जो air conditioner होता है, that's a small capacity air conditioner, we can cool it. But when you cool it in a big chilling machine, because this chilling machine is a 1,000 tons chilling machine, 2,000 tons chilling machine, 3,000 tons chilling machines. Your house chilling machine, the AC is 1.5 ton, 2 ton, and this is 2,000 ton I am talking about, 3,000 ton I am talking about. So you can understand the difference in size of the machine. One machine will take the whole size of a classroom. This is the difference. And such a big machine is to be cooled by air. In case of air, the cooling is less. Because the air itself gets hot in the summer. Water does a better cooling. But in Gulf, there is no option, so we do air cooling. And when we do air cooling, the temperature of condenser increases. The temperature of condenser increases means if you take the pH chart, this is pH chart. If you take the pH chart and if you find this condenser temperature increases, if you remember the case where condenser temperature increases, you read in the last semester, 7th semester, condenser temperature increases. As a result of that, the compressor work increases. Compressor work was earlier this much, now compressor work has become this to this. Earlier it was this to this. Compressor work more means electric power consumption is more. The electric bill is more. That means a air cooled chiller always consumes more power as compared to water cooled chiller. An air cooled chiller consumes more power as compared to water cooled chiller. But the installation cost in air cooled chiller is less because you are having only fans or blowers for air cooling. But in case of water cooled system, you have to put a cooling tower. A cooling tower costs 1 to 2 lakhs or maybe 3 lakhs depending on the capacity of the cooling tower. You have to cost a cooling tower, and cooling towers, 2 cooling towers working, 1 cooling tower standby, so it increases a lot of cost. But your operating cost decreases. That increases your installation cost, but operating cost decreases. That's the advantage of the using water cooling system. And when you are using the water cooling system, the water gets better cooled. And water being better cooled than air cools the condenser better, and the performance of the chilling machine increases. This is a great advantage with the condenser water system. In India, we generally use, because water is still now not so scarce, though it is scarce in South India more. So what happens in Southern India like Chennai, we are generally using their air cooled system, Because one problem in Chennai, the river is generally dry. There is one problem. And second problem is that seawater is available. So wherever seawater is there, you cannot use the cooling tower. Because it is the marine water is salty. So we are not using the cooling tower in case of seashores where river is not abundant, like Gulf countries and southern part of the country. But in Delhi, in Kolkata, we are using this because water is abundant in such places. Now I'll tell another thing. This cooling tower performance differs from place to place. In Delhi, the cooling tower performance is like that. This temperature of coming out to cooling tower is 97.5 degree Fahrenheit. At this temperature, it comes out of the condenser. At 97.5, it enters here. It enters here. It enters here at 97.5 degree Fahrenheit. And it comes out at a temperature of 90 degree Fahrenheit. This temperature it is coming out is 90 degree Fahrenheit. That means delta T is 7.5 degree Fahrenheit. This water at 90 degree Fahrenheit comes to condenser, picks up heat from the condenser of the chilling machine and gets heated to 97.5 degree Fahrenheit. That means it comes at a temperature, here I am making the changes, it comes at a temperature of 90 degree Fahrenheit and it gets heated to a temperature of 97.5 degree Fahrenheit. I made changes. It was earlier being cooled in case of chilled water system to 54 degree Fahrenheit to 44 degree Fahrenheit. Now I am the water this water gets heated up because it cools the refrigerant to a temperature 90 degree Fahrenheit to 97.5 degree Fahrenheit. So at 97.5 it again enters the cooling tower and at 90 degree Fahrenheit it comes back and the circulation happens. You have to understand that connotation clearly. This is how the whole system works here. This is how the whole system works here. This is the condenser water system. Remember, here the delta T is 7.5 degree Fahrenheit. That gives you a GPM of 4 US GPM, US gallons per minute per ton in case of condenser. I gave you a calculation of condenser. Remember, that I showed you earlier. There is 4 US GPM per ton. It is 2.4 US GPM per ton in case of chilled water system. It is 4 GPM per ton in case of condenser water system. Why more water is required in condenser water system? Because as you have seen in the vapor compression system, after getting through the evaporator, the compressor work is added to it. So it gets more heated. And to suppress that heat, there is 25% more addition of power. And that is why the power increases 25% more in case of cooling tower selection. We select also cooling tower for 100 ton chilling machine. We select a cooling tower of 125 ton. This is how it is done. The circulation because of the compressor work addition. I think it is clear to you. This is the condenser water system in total. This is how the condenser water system works. And this is how you will have the pot strainer and other systems in place. And the legends, already I have explained the butterfly valve is an isolating valve. The balancing valve is it balances water, regulates water. The check valve remains after pump to make a uniflow direction. That is, it flows in one direction, it goes through the pump but doesn't come back to the pump so that there is no accident. Hvac strainer, which cleans the water system. I already mentioned in the last class, Hvac strainer is available in your house drain pipeline also. If you have a drain pipeline on the top floor of the terrace and water coming out from there, you open the drain pipeline Hvac strainer, all the darts will come out. So that Hvac strainer is here. We are putting into this system Hvac strainer. Instead of Hvac strainer, we put pot strainer here. In the case of pot strainer, because why pot strainer? In case of Hvac strainer, in place of Hvac strainer, because cooling tower is a big system. The voice trainer cannot clear a cooling tower. And also, cooling tower is an open system. This is a cooling tower. This is open to the environment. This blower, through blower the air is passing out. They are open to the environment. So dust particles and other many fouling factors, leaves of trees and all these things get accumulated here. So these are to be cleaned, and this cannot be cleaned by voice strainer. Voice strainer gets choked. For that reason, pot strainer is used in this system. Pot strainer is a big strainer. That's a filter only, water filter, but a big filter as compared to the voice strainer. This is how the system works in totality. And this is how the whole circulation takes place. This is the condenser water system, and that was the chilled water system, and this is the way the whole system circulates. Important point you have to remember. Here, in case of cooling tower, the surface area increases. You know Q is equal to UA delta T. You have already read in heat transfer. Q is, the heat transfer is directly proportional to area. The more the surface area increase, more is the heat transfer. Taking that into consideration, I have sprinkled this water into small droplets so that the surface area increases tremendously. And because of this increase of surface area, the heat transfer increases. And as the heat transfer increases, the water gets cooled and is being supplied again and again. This is how the whole